And now for the ICM CFD meshing, we have to open the ICM CFD from start menu. And before importing any geometry, I'm going to save project in the same working directory, which is in the E. And it's a circular cylinder. Okay, and let's say this is going to be the coarse mesh. Okay, and now import geometry. You can import geometry by the legacy options like these, faceted like the ICM CFD mesh, STL. But we use, usually speaking, we use the import model option, which is the new in the last couple of generations in ICM CFD. So open geometry. And you have to process name selections and uncheck option for create material points, because we do that thing by ourselves. So we have the cylinder here, so you can right click here and click on good colors, and you can also right click on the curves and make them as white. Now you can see them in a clear. Okay, you can also display points. Okay, so you can see that we have these boundary conditions, and the one part that is not created here is for points. So I will create this point and I will put all the points in that particular part. Why? Because in 2D case, the points does not have to play any part in the boundary conditions, so that will not be exported. So they have only role that the mesh should be assessed properly on these points. That's the only function of point that they help to adjust the mesh on the sharp corners. Otherwise, there's no function. So they will not be part of the any boundary conditions. So therefore, I will be putting them into the one single part and click here. Okay, and then I will be creating the one material point. Although for 2D case, it's not required, but you can do it. Okay, so now last thing is that I will delete these things from here. This is the geometry, and I don't require this thing. So you can again save project, that's all. Okay, and now I'm going to open the blocking tab, and from here I'm going to create the block, and I put the name as a fluid. So for 2D case, you can define the material point while you create the block. So this block name will serve as a material point, or the region where the mesh will be generated. So this is going to be the 2D planar, and click on apply. So if you hide the curves, first I will be removing the white. So if you hide the points and curves, you can see the blocking. This is the one single block. Okay, now I need to create few points here on the geometry. So the first thing is that I am going to create the one point at 50% location over here, then 25%, which is here, then 75%. Okay, and then I will be splitting the points, the curves at these points. So choose curve option, and second row, second option. So choose curve and choose these 4 points. So now we have the 4 curves here. So the next thing is that I will be deleting these 4 points. I don't require these 4 points here, and I will create new points that will be the middle of the each curve. So this curve, this curve, this curve, and this curve. So 4 points, and this will help to will adjust my blocking on the cylinder geometry. Okay. So first of all, now after making these points, I'm going to associate these corner vertices with the corner points. In this way, choose first vertex and then point on the same location. And then I have to associate each edge to the corresponding curve. So one edge and one curve here. And after doing this thing, the edges will have the green color. And this is still not associated. This shows that this is not this part of any particular curve. So this is associated to the corresponding curve here. So last one is over here. Choose the edge and then curve. You can save project again. And now we have to split the blocking at these points. Okay, so use a split block and choose any vertical edge and then from options choose prescribed point. Similarly on the bottom side, and in a similar way we will make the vertical splits on the horizontal lines. So choose any horizontal line and choose this point and this point. Okay, so basically we made the 4 edges for this circular cylinder. So I'm going to associate these 4 edges to 4 curves. Okay, and right click on the parts and click on create part. So I will be making this blocking into another part from the fluid to the solid, because we don't require any mesh inside this part. So this should be a separate material point or the blocking material. Okay, you can see the color also. This is now in the dark green color, and you can also show them from the blocking and blocks. So we have the 9 blocks, and out of 9 blocks, the 1 block is inside cylinder, and we don't make any mesh inside cylinder. That's why we are making a separate material. And when you uncheck this option, the mesh inside this block will not be exported for the CFD analysis. This is the trick, that when you export the mesh, uncheck this option. Okay. And now we have to create the O grid around this geometry, this particular block. So this will be the serve as the O grid around the circular cylinder, and rest of geometry, rest of blocking will give you the H block. And this is what we discussed earlier, that the mesh type is O and the H. OH. O is around the cylinder and H the rest of the domain. So we have to make one O grid around this geometry. Make it around and make the offset maybe 0.2. We try different values. Okay, this seems nice. Okay, this seems okay. So maybe you can increase the dimension by 20%. So edit block, rescale O grid, choose any diagonal edge, and offset by, let's say, 30%. This seems okay too. So next thing is that we have to adjust the blocking. These vertices are here and this one is here. So they should be in the line. So I will choose the third option. I will choose the edge and then the one vertex and apply. Similarly, this horizontal edge and this vertex and apply. So this will align the remaining vertices based on this edge. So you can again save the project, and inside the circular cylinder I am going to provide the very fine mesh, and this will be based on my own experience. So I am going to provide, like, for example, number of nodes may be 60, and this is the side number 2 is over here. So I will use the geometric 2. And I will be putting the size maybe 0.00001 and ratio is a 1.15. And choose option copy parameters to all parallel edges and apply. Okay, next thing is that I'm going to provide the number of cells here. So initially in the coarse mesh 20 and then 20. Okay, now I will be checking the mesh. So you can hide the solid body. So this mesh will look like in this way. So I recommend that we can check the pre-mesh size. So pre-mesh and pre-mesh info is around 4000. So let's increase the number of cells slightly higher. So 70, and the ratio I'm going to set is a 1.2. Okay, right click here on the pre-mesh and recompute. Okay, so and one more thing is that I know that the water shading is very important, at least 5D. So 2Ds are I think are already there. So I'm going to make the one split at 3D, means almost 3 times. So 3 times would be maybe over here. So make a one split over here, simple, like this, maybe over here. Okay, So why? Because I'm going to provide the very fine mesh in this region. So I'm going to put the number of cells maybe 80, and I will make it geometric 1 because the side number 1 is over here. Okay, before that I'm going to copy the meshing parameters from this edge to this edge, this edge to this edge, and from this edge to this edge, and also this edge to this edge. Okay, then I'm going to provide maybe very less cells here, maybe 25, and make it bigeometric and let's copy the parameters again. So okay, and now again check the mesh here. So okay, so we have the sizing applied on the edge number 2, which is the 0.4. So provide the ratio as a 1.1 and right click on the pre-mesh and check. I think we should be using the geometric 2 here, and apply and again check pre-mesh. So there should be more refined mesh towards circular cylinder. Okay, and also the spacing has been copied on this edge, so I will be providing 80 cells here, and the ratio I'm going to provide is, okay, let me copy them again. Okay, so from this cell to this cell, from this edge to this edge. Okay, so spacing is right now is the 0.4. Ratio is 1.2. Now let's check the pre-mesh. Okay, so we have the more refined mesh here, and also I'm going to provide the, instead of 20 cells, I'm going to provide like the 40 cells. Okay, so 40 cells here also. Right click on the pre-mesh and recompute. Okay, so we have to reduce the number of cells here. Okay, let's say we try with 50 cells. Okay, one more thing I'm looking at is that I should be using, I think, bigeometric. This will make the things better. So bigeometric and see the mesh now. So this is making like more uniform mesh outside, and if I go with the geometric 2, geometric 1, and ratio is a 1.05. Okay, right click here and recompute. It should be geometric 2, right? Okay, so pre-mesh and recompute. So this seems okay. So now it means that now we have to reduce the number of cells here as well. So copy spacing from here to there, and make number of cells maybe 30, and recompute. Okay, now we have to define number of cells here as well. So here I'm going to define the number of cells as 30. But I will use a geometric 1 here. I need to have the more cells here because a wake will be formed and this may go in this way. Okay, you should be very much careful about the meshing here because the meshing is not very simple here and it requires a lot of considerations. So geometric 2 would be applicable here. Let me try. And 20 cells. Okay, so 20 cells were upstream. On the upper side, 30 cells are here, so 30 cells should be here as well. Okay, one thing which I'm observing is that maybe this O grid is very large. So again, I will go to edit block, and from here I will reduce to the by maybe 70%. Okay, so again I'm going to set the blocking in this way, and also for the vertical one. Okay, so again the last thing is the downstream block, and I will again get the blocking dimension from here, and put the number of nodes, maybe 20 will be sufficient here. And recompute. So you can see the mesh looks like in this way. So let's check the number of cells here. So 20,000 around, and so this corresponds to the like a medium mesh. Okay, and a few more things which I have to make here is that we have to make these edges round. So I'm going to copy the edge shape from inside to outside. Okay, so make the ratio initially factor as a 1, and you can go up to 3 factor. So they should be 100% round. Yes, this is okay. And then corresponding edges over here, then here, and then here. And you can try with maybe 1.5. No, I think this is going to be distorting more. So let's try with the 1.2. Okay, let's make it 1.1. Okay, once again we have to adjust the sizing. So copy sizing from here to there. And then to apply on edges, all edges, we have to choose a particular edge and apply them all. So choose the edge here and apply them all. Okay, and right click on the pre-mesh and recompute. So now let's compare with the already provided mesh. This is also looks similar. Okay, so if you hide the edges and adjust the blocking, okay, you can also change the color. So for example, right click on the fluid and change color to, let's say, to the pink, like this, or maybe the blue color, like this. You can also change the color from the color plate. So you can also have the color like this. Okay, now hide points and curves, and this looks very, very nice mesh here. Okay, so now I'm going to convert this mesh into the unstructured meshing. So right click on the pre-mesh and convert to unstructured mesh. So this will look like in this way. And the last thing is that we have to export the mesh. So first of all, select the solver. It's Fluent by default. Click on OK. In the boundary conditions for edges, like the bottom is a symmetry. Okay, copy this one and paste same thing on the top boundary. You can see in the white color. And for inlet, this is going to be the velocity inlet. and for outlet this is going to be the pressure outlet, and for the cylinder this is going to be the wall. Okay, and we have these things, surfaces. Okay, this can be defined as the fluid, okay, or the interior, basically interior. Okay, okay, and accept. Okay, so save the project again, and then export the mesh. Okay, I will call this mesh as coarse mesh. Okay, so I am calling the 20,000 cells as the coarse mesh. Why? Because the case you are seeing here is solved like 10 years ago, and at that time I had the computer which had only 4 GB RAM, and it was the very old generation, like before the, it was, I think it was the i5 second generation. So now I have the better computer, 32 GB RAM with a faster CPU. So I think now at this time, we can comfortably increase the number of cells for the coarse mesh to 20,000. Then medium mesh would be like 40,000, and the fine mesh would be 80,000. Okay, so now we have exported this mesh also. And if you take a look on the mesh quality from edit mesh, and the mesh quality, this is right now it's more than 0.9. And if you take a look on the minimum orthogonal quality, you can also do it from here. So it's a 0.75. And in the this particular PPT file, you can see it's a 0.75. And keep in mind this thing, this was generated like 10 years ago. But I'm going to share with you these files, these 3 files, coarse, medium, and fine. But I will use a new mesh which is almost similar to the medium mesh which is over here. Okay, so for demonstration purpose, I will use only one mesh that is equivalent to medium mesh. But the files I'm going to provide you, these are these all files which you can see over here. Okay, I think I made a one mistake. So the mistake here is, I want to show you from the videos that when I was exporting the mesh file, so at that time I didn't select the 2D option. So it's a 3D. So but this is a 2D mesh, and we have to select the 2D option here. So again, once again I will export the mesh, and this time make sure, so click on open, everything is there. Click on the 2D option, and again put the name which is the cylinder coarse. Okay, that's all about this ICM CFD part.